Okay, welcome to Mastermind Scholars Educational Alliance. This is lesson 8, that is multiplication law of probability. At Mastermind, we dream, we believe, and we achieve excellence. All right, let's move on to multiplication law of probability, and then we are done. Now, when we talk about multiplication law of probability, we are talking about the law that is used to find probability that two events happen together. That is A and B both should occur. Now it allows questions like, what's the probability of A and B both occurring? So A occurs, B occurs, they should all occur in that regard. There are two types. You have independent event, we have dependent event. When we talk about independent event, two events are independent if the outcome of one does not affect the outcome of the other. And then in probability, the terms "and" means both events happen together, because Kofi and Ama, so all of them. Kofi or Ama is like the addition law. For that one is the addition law, because it can be Kofi or Ama, either Kofi or Ama, any of them. So we add. But in multiplication law, both of them should occur at the same time. So Kofi and Ama, or in the probability terms, "and" is used. I put more emphasis on the "and." So in any question, when you see "and" in probability, we are talking about multiplication. Then the formula is given by this. So that is independent event. With independent event, the outcome of one does not affect the outcome of the other in that regard. Now, so you have A and B, and that is A intersection B should give you P of A multiplied by P of B, which is probability of A and the probability of B. Now let's look at question 1. A coin is tossed and a fair six-sided die is rolled at the same time. What is the probability of getting a head on a coin and a 5 on a die? So with this particular question, we have get event A of getting a head is 1 out of 6. Event B of getting a 5 is 1 out of 6 as well. So since one does not influence the other, the outcome of getting one does not influence the outcome of getting another, because when you take out the head on a coin and you take out a die, those two, coin and die, will not affect each other in terms of their outcomes. Okay, so because they will not affect each other in terms of their outcomes, we have this particular rule to help us to be able to simplify. And this rule is a rule for multiplication law of probability that consists of an independent event which do not actually affect the result. The event of one does not affect the result of the other one. So then we have 1 out of 6 over 1 out of 6, and we have 1 out of 36. Let's look at another question. A standard deck of 52 playing cards are shuffled, and one card is drawn at random. At the same time, a fair six-sided die is rolled. What's the probability that the card drawn is red and the die shows a 4? How can the outcome of a die affect the outcome of a coin? They are two different things, and when they are rolled together, tossing a die and a coin, tossing a coin and rolling a die will not affect each other in terms of when you are putting them in events. Or event A happening, first toss a coin and you toss a die. It will not happen that the result of the die will affect the result of the coin. It can't happen that way. In that sense, we have event A drawing a card from a deck, 1 out of 2. That is, it will be 26 out of 52. Because there are 26 red card out of 52 there. You probably might not know this, but those are the number of red cards in a deck of cards. Then we have rolling a 4 on a fair-sided die, 1 out of 6. Since drawing a card does not affect rolling a die, the events are independent. So we use the multiplication law to figure it out. Then we have 1 out of 2 times 1 out of 6, then we have 1 out of 12. Let's look at another question. This is not another question, a dependent event. Now, dependent events are two events that the outcome of one affect the outcome of the other. So two events are dependent if the outcome of one affect the outcome of the other. Look at the formula. Okay. Now what here? So we have where P of A is the probability that A happens first, and A of B, and then A in the bracket like that. This is the probability of B given that A has already happened. So this one, the probability of A affects that of B in that sense. So A happens first and B occurs second. So question 1. A bag contains 5 red balls and 3 blue balls. The balls are drawn one after the other without replacement. What is the probability that both balls are red? They are drawn without replacement. So when you draw a first one, it affects the chances of the second one. And in that sense, you have red balls 5 over 8. The second one, after one red is removed, will be 4 out of 7 because the total will be reduced to 7. And the red ball will be remaining with 4, not 5 anymore because one is already out. So 4 out of 7. Which then gives you 4 out of 7, which then gives you 5 out of 8 times 4 out of 7 would give you, I think, 20 over 56. And that cancels out to be 5 out of 14 in that sense. Now watch your question 2. In a class of 10 students, 6 girls and 4 boys, 2 students are picked out without replacement. What's the probability that both students are girls? So we have first girl is 6 out of 10, which is 3 out of 5, because the total number of students in the class is 10 and the girls are 6. Cancel out or simplify, get 3 out of 5. Right? 3 out of 5, right? Now you have second girl is choosing at the expense of the first one out of the class. It means that it's been affected. So if it's affected, then the total number of girls will be 6 anymore. There will be 5 now. And the total number of students in the class will be 9 now. So 5 out of 9. So if you are asked to find probability that both are girls, then you need to multiply the two together. That gives you 15 out of 45, which ends up to give you 1 out of 3 if you simplify. So